Alright, in the last lecture we have learned how can we search for a node in a circle single linked list. Now in this lecture we are going to talk about deletion of a node from circle single linked list. Now we know from the previous lectures that to delete a node from a linked list we have three cases. So these cases are applicable in case of circle single linked list as well. So here in this case we can delete an element from the beginning of this circle single linked list. So in this case if we delete node 1 from here, it means that we are deleting first node. Then the second case is we are deleting any given node between these nodes. For example, if you want to delete node 2, so this is belong to this second case over here. Now the last case is we want to delete a node from the end of circle single linked list. Now in this case, if you want to delete node 4, in this case we are deleting last node from the circle single linked list. Now let's see how these cases works one by one. Now when we are deleting a node from the beginning of circle single linked list, we have two cases over here. The first case is if we have only one node in our circle single linked list. So in this case, all we have to do, we have to set all references to null, which comes to this node over here. Now you can see from this picture that head references to this node, tail references to this node, and this node also references to itself. So by updating these references to null, we can delete this node from circle single linked list. Now the first step is we are going to set head to null. So if we set head reference to null, the link between head and this node gets destroyed. Then the next step is we are setting tail reference to null. Now if we set tail reference to null, the link between tail and this node will be destroyed. Now in this case we don't have any link to this node. Now we know that if we don't have any link to this node, the garbage collector recognizes this as a garbage. It's destroying it from the memory. But in this case it cannot destroy it because in this case this node references to itself. So we have to delete this reference also. So if we set this node's reference to null, the link between itself gets destroyed. Now after doing so, this node is not linked by anyone over here. So this means that the garbage collector comes and destroys this node from the memory. So with this, we have successfully deleted a node from the circle single linked list in which we have only one node. Now the second case of the deleting the first node is if we have more than one node. Now in this case the steps are different. So the first step that we are going to do, we have to change the reference head to point to the second node. So this means that head reference will be updated with the physical location of the second node. So in this case the physical location of second node is 111. So we are going to set head reference to 111. Now if I set head reference to 111, a link between head and this second node is created. Now when we are creating a link between head and this second node, the link between head and first node get destroyed, and the link between first node and second node is also gets destroyed. Now the next step is we know that in case of circle single linked list, last node has to point to first node. So if we are deleting first node, so the second node becomes the first node. So this means that we have to update the last node's reference to point to this second node over here. Now we know that the second node's physical location is 111, so we are going to update the last node's reference to 111. Now when we are updating it, a reference between last node and second node is created, and this means that a reference between last node and the first node gets destroyed. Now with these steps we see that this node, the first node over here, is not referenced by any node, so this means that garbage collector can come and destroy this node from the memory. Now with this we have successfully deleted a node from the beginning of the linked list in which we have more than one node. Now we are continuing to the second case in which we can delete a node from any given location. Now let's say if we want to delete node 3 from here, the first step that we are going to do, we have to loop through the circle single linked list until we reach to the node which is located before the node that we want to delete. So in this case, if we want to delete node 3, we have to loop until node 2. Now when we loop over here, we are going to change node 2's reference to point to the node which is after the node 3, because we are going to delete the node 3. So this means that we are going to update node 2's reference to point node 4 over here. Now you see that node 4's physical location is 333, so we are going to set node 2's next reference to 333. And by doing so, a link between node 2 and node 4 is created. Now when we are creating a link between node 2 and node 4, the link between node 2 and node 3 gets destroyed, and the link between node 3 and node 4 gets destroyed. Now as you can see, node 3 is not referenced by any node over here, so this means that garbage collector will delete this node from the memory. Now with this, we have successfully deleted a node from any given location in case of circle single linked list. Now we are continuing to the last case in which we are deleting a node from the end of circle single linked list. Now here also we have two cases. The first case is we have a single linked list like this in which we have only one node. Now this case is similar to the case where we are deleting a node from the beginning of circle single linked list, because if we have one element, it means that this is first element and this is also last element. So here also the steps are same. So we are going to change the references to null. So this node will not be referenced by any node. So this means that the garbage collector will delete this from the memory. So the first thing that we are going to do, we are going to set head reference to null. So when we are setting head reference to null, the link between head and to this node gets destroyed. And then we are setting tail reference to null. Now when we are setting tail reference to null, the link between tail and this node gets destroyed. Then we have to delete this link from itself, because if it is referencing itself, we cannot delete it from the memory. So garbage collector does not recognize it as a garbage. So that's why we have to set this node's next reference to null. So by doing so, the link between itself gets destroyed. Then this node can be deleted by garbage collector. Now the next case is we are deleting the last node in which we have more than one node. Now in this case, if we want to delete last node, in this case it's going to be node 4, the first thing that we have to do, we have to loop through the first node until to the node which is located before last node. So we are going to loop through this single linked list until we reach the node which is located before the last node. Now in this case, node 3 is located before the last node, so when we reach node 3, we are going to stop here. Now the first thing that we are going to do, we are going to update node 3's next reference to point to node first, because we know that in case of circle single linked list, last node has to point to first node. So in this case, we are deleting the last node from here, so this means that node 3 will be the last node. So we are going to update node 3's next reference to point to node 1. Now the physical location of node 1 is 001, so we are updating node 1 over here to the next reference of node 3. So with this, a link between node 3 and node 1 is created. Now when we are creating a link between node 3 and node 1, the link between node 3 and node 4 gets destroyed. And here also, the link between node 4 and node 1 gets destroyed. Now the next step is, now we know that in case of linked list, tail has to point to last node. Now in this case, the last node will be deleted, so this means that node 3 will be the last node, and the physical location of node 3 is 222. So we are going to set the tail reference to 222, and with this, a link between tail and node 3 is created, and a link between tail and node 4 gets deleted. Now after doing so, we see that node 4 is not referenced by any node, so this means that garbage collector can come and delete this node from the memory. So this node gets deleted from the memory. Now with this, we have successfully deleted a node from the end of circle single linked list in which we have more than one node. Now with this, we have come to the end of this lecture. So in this lecture, I have shown you how the deletion occurs in 3 cases. So in the first case, we are deleting the node from the first of circle single linked list. Then we are deleting a node from the any given location in circle single linked list. And finally, we are deleting a node from the end of circle single linked list. Now based on this logic over here, let's see in the next lecture how the algorithm of deletion looks like.